Alright, we're going to work on a very useful, actually basically the primary idea behind trigonometry, something that's very useful throughout all of trigonometry. It is the Pythagorean Theorem. And we're just going to start out here with the way that it's usually expressed. A squared plus b squared equals c squared. And that means that if you have a right triangle, no matter as long as this is 90 degrees, no matter the differing amounts here, if these are 30 and 60 or 45 and 45, you can figure out that this is the A, this is the B, this is the C. So that if you knew any two, you could figure out the third one. And the very classic, probably the most classic right triangle is the 3, 4, 5. Meaning if this were a length of 3, this were a length of 4, and this were a length of, this then has to be a length of 5. You say, well, how do you figure that out, or how do you prove that? Well, if you use the Pythagorean theorem itself, 3 squared, which is what the A would be, plus b squared, which is this side, 4 squared, you can work the equation out. So 3 times 3 squared is 9, plus 4 times 4, which is 16, equals c squared. So 25 equals c squared. You're almost done here. You just have to work out here that the opposite of squaring something is to square root it. And the square root of 25 is 5. Now, you might say, well, that looks nice and fancy, and you did all the algebra, and I see that you did the algebra, but what does it mean? Why does it work? Or why should it work? Or why should I think that it works? Well, let's work it out a little bit. The idea is that, let's draw a coordinate plane here. The idea is that if I had a coordinate plane, and let me try and draw this pretty nice. If I had a coordinate plane and I put a triangle inside of here, such as I put the beginning of it right there, and I went over 3 this way, 1, 2, 3, and 4 up, 1, 2, 3, 4 up, that you would find out what that is automatically, like we said. But let's look at what this means. If this is 3 here, and this is 4 here, the squaring part, when you're squaring something, the idea, or the square root of something means this. If you had a square of 9, and you knew the entire area is one side times another side, was 9. That means that what made the 9 was 3 on each side. Because 3 on this side and 3 on this side, if you were to draw this out, you would get 9 little squares. Because 3 times 3 equals 9. So the same thing with 4 then. If you had a slightly larger square and there were 4 sides to it, and you knew then that this had to be 16, it's because there's 4 times 4 and all the little squares worked out together. If you progress all these out and counted all of them, you'd have 16 little squares. Okay, so let's do that in here. That means that you have a rather small square compared to the other ones, a rather bigger square, and then on this side you would be able to fit point to point the bigger square, the biggest square, 5 by 5. Because this area would be 5, this length would be 5 here, this length would be 5 here, and then 5 by 5 is 25. This is 9 and this is 16. So you can see where the numbers came from again, because we had a squared, this is a, b squared, this is b, equals c squared, this is c. So 9, that's 9 from this, 9 plus 16 equals 25. That is the basic idea of why the Pythagorean theorem works and how you can use it. Now let's go on beyond this and let's look at the things that will reoccur very frequently throughout trigonometry, throughout all of mathematics for you. If you're using triangles, you're going to see the root of it is the Pythagorean theorem. You're going to have the 30, 60, 90, the 30, 60, 90 triangle, the 45, 45, the 45, 45, let's erase all that. And what the lengths that coordinate to these are, what correlate to these. So I'm going to just write it out, then I'll explain it. The 30, 60, 90 lines up to be a 1 square root of 3, 2. The 45, 45, 90 correlates to be a 1, 1 square root of 2. Now what that means is, and I know that this seems obscure and you don't know why that is, but over and over again you're going to see these numbers, especially in the unit circle. You're going to see these, the unit circle. You'll get to that later. I won't go too far right now, but what that means right now is that if you had a right triangle of 30, 60, 90, that the length across from the 30 would be the smallest, would be 1. The next smallest, even though the 3 looks bigger than the 2, if you're not familiar with square roots, it's the square root of 3 and then 2. And that's the standard ratio, the standard form of what the lengths will be in relation to each other. And then the 45, 45, 90, when these sides are 45, 45, and 90, it will be 1, 1 square root of 2. And now, I'm saying that, and you go, well, that must just be the way it is because that's special, but it actually fits directly into the Pythagorean theorem. So if I took a, which is 1 here, and square it, plus, and say I didn't know this one, say that I'm trying to find this one, call that b, equals, and I know this, 2 squared. So this is 4, this is 1, and this is b, because 1 squared is 1 and 2 squared is 4. So then I subtract the 1 to this side, and I get 3. So, but I have b squared. So that b equals the square root of 3. Now, that's the idea is that these are universal ratios, and it's called the unit circle because unit means when you are at a distance of 1. When this length to this length is a distance of 1. Right now I'm getting a little far ahead of you, but I'm saying this is super valuable. This is, once you know this, you know 70% of what trigonometry is based on. It'll fan out afterwards, but this is the core 70%. This Pythagorean theorem, the 30, 60, 90, the unit circle information, and these ratios are going to reoccur over and over and over again.